Starting out with resting membrane potential, this describes the electrical potential of the plasma membrane when it's at rest. And this is when the ICF measures to have a value of negative 70 millivolts. So down here, this would be when we're at resting potential. And then when there's stimulation, depolarization starts to make things more positive, and then you move into local potential. And local potential is a short-term change in voltage along the plasma membrane, and this happens when it moves from negative 70 to negative 55. So local potential happens right within that scenario, within that place there. And then this part is reversible. And then after this, that moves into action potential. And action potential is a more dramatic change in the state of the plasma membrane as it moves down the hillock along the axon's length. So this is depolarization, and this is action potential. And it happens up until around positive 40 millivolts, and then after that it starts moving back down and repolarizes down, and then it ends up stabilizing back down into the negative 70 millivolts. And to describe a little bit more how this works, depolarization happens when sodium ions diffuse rapidly into the ICF here, making the ICF more positive. And then repolarization happens when potassium ions rapidly diffuse back into the ECF, bringing the ICF back into a resting state that is negative.